Very good morning, students. For this lecturing video session, I'm going to solve a problem from support reactions. So let me just read out the question and what has been asked and what the diagram says. Find the support reactions of a simply supported beam as shown in figure, and the figure is given. So simply supported beam in the sense, both the ends are supported with support. There is one end it is with roller support or rocker support. The other end it is with the pin joint or the hinged support, isn't it? So first what we have to do is, so to draw the free body diagram. So first I need to draw the free body diagram to proceed the sum or the proceed the problem, isn't it? So I thought you, when the rocker support is given, the reaction force would be, there would be only one reaction, isn't it? See, as far as hinge support or the pin joint support is concerned, there will be two reactions. One would be the horizontal, the other one would be the vertical, isn't it? So let me just draw the FBD first. So let me just take the reaction for the rocker or the roller support. So it is acting at A point. Let me just take this as vertical force, that is vertical reaction at point A. And this is the beam. The other end is supported with the hinge support. Hinge support will have a horizontal reaction. So at point B, therefore horizontal force at B, and there will be a vertical reaction. So let me just consider this as B. There is a vertical reaction at point B. So there are 2 point loads which are acting. 2 point loads of magnitude 4 kilonewton and 8 kilonewton, isn't it? So let me just mention the distance between each reaction and force. So let me just give the naming for this. Since A and B is given, let me just give the naming for this as C and this as D. Between A and C, it is 2 meter. Between C and D, it is 4 meter. And between D and B, it is 2 meter. Right. So now I am going to apply the equilibrium condition. Applying equilibrium condition. So when you draw the FBD, so by default you will have to apply the equilibrium condition, because when you just draw the FBD, there will be unknown. So when there is an unknown force, you will have to apply the equilibrium conditions. What it says, the sum of horizontal force is equal to 0, sum of vertical force is equal to 0, and the sum of moment equal to 0. Right. Now I'm going to resolve the horizontal forces first. So summation of H is equal to 0. Right. Summation H is equal to 0. So 0 equal to, how many horizontal forces are there? Look at here. This is vertical, 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 and this is vertical, and this is horizontal, which is acting in the positive x direction. So as I taught you in the resolution of forces, when it travels here, this would be a plus x direction, and when the force acts in this direction, minus x, and when the force acts vertically upwards, positive y, and when the force which acts in the vertically downward direction, which will be minus y. So you have to just remember this, right? So 0 is equal to HB. So therefore HB equal to 0, isn't it? Now I am going to resolve the vertical forces. Summation V equal to 0. So how many vertical forces are here? So as far as this diagram is concerned, so 1, 2, 3, 4 vertical forces are there. So 0 equal to, so VA acts in the positive direction, so VA. Then this 4 kilonewton which is acting in the negative direction, so minus 4, and 8 again it is acting in the negative direction, minus 8. And VB which is acting in the positive y direction, therefore positive sign VB. Right. So 0 is equal to VA minus 12 plus VB. Right. So let me just take this VA plus VB equal to 12. Let me just take this minus 12 in the left hand side. Therefore, the minus sign becomes positive. Right. So VA plus VB equal to 12. Let me just consider this as equation number 1. So next I need to take the moment. So taking moment about the point A, So I'm going to take the moment about the point A. So summation MA equal to 0 because applying the equilibrium condition here. So 0 equal to, look at here a force is there, VA, but it doesn't have any, since it is an origin, so therefore there is no perpendicular distance. So moment is the product of force and its perpendicular distance. Here force is there but there is no perpendicular distance, therefore this becomes 0. Let me just move to the next point C, wherein a force is acting right vertically downwards. When it acts in this direction, it tends to make the moment in the clockwise direction. When it pushes down, it tends to move in the clockwise direction. Therefore, there you have positive sign, and the perpendicular distance would be from the origin to C is 2 meter. So force is 4 kilonewton, and the perpendicular distance is 2. Let me just move to the next force at point D of magnitude 8 kilonewton, which is acting vertically downwards. Right, this is how it is acting. When it pushes here, the one end is fixed, the other end, if it tends to move in the clockwise direction, right, the tanning effect will be in the positive direction, that is clockwise. Clockwise is positive direction. So plus 8 into its perpendicular distance from the origin is A. So from A to D it is 4 plus 2, it is 6. Right. And let me just move to point B, wherein a horizontal force is HP, but it doesn't have any perpendicular distance with the origin A. Therefore, this becomes 0. So consider here is a vertical force, that is vertically upward force is there at B, right? When the force acts from here, it tends to rotate the object in the anti-clockwise direction. Therefore, it will carry the negative sign, and the magnitude is VB into its perpendicular distance from the origin. From origin is A, so till B it is 2 plus 4 plus 2, which is 8. So 0 is equal to 8 plus 8 into 6, it is 48 minus 8 VB. Right. So let me just take this minus AB in the left hand side direction. So it becomes 8 VB equal to 48 plus 8, which is 56. So therefore VB equal to 56 divided by 8. 56 divided by 8, which works out 7 kilonewton. The unit which is mentioned for the point load is kilonewton. Therefore the reaction, the unit of reaction will be also in kilonewton. So VB equal to 7 kilonewton, isn't it? Right. So in the equation 1, what it says, VA plus VB is equal to 12. So VB has been arrived here. So I am going to apply or the substitute this VB value on equation 1. So substituting VB value in equation 1. So VA plus 7 equal to 12. So VA equal to 12 minus 7. So therefore VA equal to 12 minus 7, which is 5, and the unit of reaction is kilonewton. So right, at last you have to mention the result. So VB equal to 7 kilonewton and VA equal to 5 kilonewton. Hope you have all understood how to solve when you have such problems from the support reactions. Thank you.